So you threw your waste in a recycling can. Congratulations, you fulfilled your duty as a citizen. Or did you? It's easy to forget what actually happens to our waste, but there's a lot more to the recycling process than you may think. In fact, you'd be surprised to know that only a portion of the material is actually recycled. What happens to the rest of it? The recycling journey begins with the collection of recyclable materials. This can take place through various methods, such as curbside collection programs, drop-off centers, and commercial recycling services. To facilitate efficient sorting and processing, it's essential for consumers to separate recyclables, including plastics, paper, glass, and metals from non-recyclable waste. The collected material then arrives at a material recovery facility, MRF, also known as a recycling plant or recycling center. It's a crucial hub in the recycling process where recyclable materials are sorted, processed, and prepared for further recycling or manufacturing. These facilities can be anywhere from 7,000 to 8,000 square meters in size and sort 400 tons of waste every day. Here's what typically happens at an MRF. When recyclables arrive at the MRF, they are unloaded from collection trucks and brought to the facility's tipping floor. Here, workers or automated equipment may perform a quick initial inspection to remove any obvious non-recyclable items, such as large trash or hazardous materials. After the initial inspection, waste is pre-sorted. In this process, large or easily identifiable items that are not part of the recyclable stream, cardboard, large plastic items, are manually removed. After pre-sorting, MRFs employ a combination of manual labor and advanced sorting technologies to separate recyclables efficiently. Automated conveyor belts, screens, air classifiers, magnets, and optical sensors are some of the equipment used to sort materials based on their properties, such as size, weight, shape, and material type. These rotating cylindrical screens separate materials based on size. Smaller items fall through, while larger items continue down the conveyor. Powerful magnets are used to attract and separate ferrous metals containing iron, such as steel cans. These devices use sensors and cameras to identify and separate materials based on their optical properties, such as color and shape. They can sort plastics by resin type and colors. Air jets are used to separate lightweight materials, like paper and plastic, from heavier materials like glass and metal. Despite advanced technology, manual labor remains important in the sorting process. Workers stationed along the conveyor belts manually remove contaminants, as well as items that the automated systems may have missed. Manual sorting helps ensure higher quality recyclables. After sorting, the separated materials are compacted or baled. Baling involves compressing materials like paper, plastic, cardboard, and aluminum into large blocks or bales. This process makes the materials easier to handle, store, and transport. Bales of sorted recyclables are stored in the MRF until they're ready to be transported to manufacturers for further processing. Proper storage helps ensure that the quality of recyclable materials is maintained. Some non-recyclable or difficult-to-recycle items, known as residue, may still be present in the sorted materials. MRFs manage this residue, which may include items like plastic bags, food waste, and small non-recyclable pieces. Once baled and sorted, the recyclables are sold to manufacturers and processing facilities as raw materials. These materials will be used to produce new products, reducing the need for virgin resources. Many modern MRFs use data tracking and monitoring systems to measure efficiency, track contamination rates, and identify areas for improvement in the sorting and processing processes. This data-driven approach helps optimize operations and enhance recycling outcomes. Once sorted by the MRF, the materials are then transported to processing plants where they're subjected to specific processing methods based on their types. Each material type requires unique treatment to prepare it for reuse. A. Paper. Paper is often shredded and mixed with water to create a pulp. This pulp is then cleaned and refined, removing ink, adhesives, and other impurities. The resulting pulp can be used to produce new paper products. B. Plastics. Plastics are sorted by type and then undergo processes such as shredding, washing, and melting to create plastic pellets. These pellets serve as the raw material for manufacturing new plastic products. C. Glass. Glass is crushed into small pieces known as cullet. The cullet is melted down to produce new glass products, reducing the need for raw materials and energy compared to making glass from scratch. D. Metals. Metals like aluminum and steel are melted down to form ingots or sheets. The recycled metal can be used to manufacture a wide range of products, from cans to car parts. Processed materials are sent to manufacturers, who use them as inputs for creating new products. The use of recycled materials in manufacturing reduces the demand for virgin resources, conserving energy and reducing greenhouse gas emissions. The newly manufactured products are distributed to consumers through retail outlets. These products, made from recycled materials, offer the same quality and functionality as those made from virgin resources. By purchasing and using these products, consumers support the closed-loop recycling system and promote sustainable practices. Eventually, recycled products may reach the end of their useful life. At this point, some materials can be recycled again, continuing the cycle. For instance, aluminum can be recycled indefinitely without losing quality. Other materials might have limitations on the number of times they can be recycled due to degradation. Let's return to our initial question. Can all waste be recycled? If not, how much of it isn't recycled? Well, the answer is not all waste can be recycled due to technical, economic, or environmental constraints. As far as percentages go, 60% of the waste that ends up in a recyclable can is not recyclable. Here's what happens to it. A significant portion of non-recyclable waste ends up in landfills. Landfills are engineered sites designed to contain waste and minimize its impact on the environment. However, landfills can pose environmental risks, including groundwater contamination, production of greenhouse gases like methane, and the potential for long-term pollution. Some non-recyclable waste is incinerated in waste-to-energy facilities. Incineration involves burning waste to generate energy, typically in the form of heat or electricity. While this method can reduce the volume of waste and recover some energy, it may also release pollutants into the air and contribute to air quality concerns. To reduce the amount of waste sent to landfills and incinerators, waste reduction and minimization strategies are crucial. This includes practices such as source reduction, producing less waste to begin with, reusing items, and composting organic materials.